Here you can see the beautiful Eau Claire campus next to the Chippewa River. It is located in the western part of Wisconsin. It serves as an educational institution for more than 10,000 undergraduate students and faculty. In order to feed this large campus population, there are two primary food distribution centers. Both of these are supplied by a company called Sodexo. In the process of food preparation, they generate approximately 10 gallons of waste oil a day. This waste oil could be used in the campus's 16 diesel-powered vehicles, utilized for services and management. The use of these vehicles requires an average of 2,850 gallons of diesel fuel per year. That's enough to fill the Davies Fish Aquarium nearly 5 times. This is a cause for concern because the burning of diesel fuel creates emission products that can be harmful to the human health and the environment. Of specific concern is the amount of particulate matter. For the purpose of this video, particulate matter can be defined as discrete airborne particles that contain carbon and various metals that are not consumed in the burning of diesel fuel. The size of these particles can be illustrated by comparing them to a strand of human hair. Particulate matter emissions are sometimes overlooked because it does not deplete the ozone and is not a greenhouse gas. However, studies have shown particulate matter affects the human cardiovascular and respiratory system. This increases the risk of asthma, atherosclerosis, and other ailments. Particulate emissions can lead to environmental hazards, such as smog and local ecological system damage. Biodiesel has the ability to reduce the severity and occurrence of these harmful effects because it has been experimentally shown to reduce particulate matter emitted from diesel vehicles, and here's how. First, let's look at how particulate matter is created.
Here is an example of a diesel-powered vehicle that will be used to illustrate the simplified process by which particulate matter is created. To start, diesel fuel enters the engine where it undergoes combustion. Combustion is simply a technical term for the burning of a substance, like charcoal in a grill. As the fuel is burned, it produces energy that is capable of turning the wheels of the vehicle. However, this fuel combustion process also produces byproducts in the form of gases and particulate matter. These byproducts are transferred through the exhaust system to the tailpipe, where they are released into the air. Here is how particulate matter is collected from the vehicle to be analyzed. In order to capture the exhaust emitted from these vehicles, a tube is attached to the tailpipe that directs the exhaust to the primary dilution tunnel. In the dilution tunnel, the exhaust mixes with incoming outside air and is guided through the tunnel. Near the end of the dilution tunnel, there is a smaller tube that collects a portion of the exhaust and directs it through the particulate filters. There are 2 pairs of finely meshed filters that trap the particulate matter as the exhaust is passed through them. During this collection process, the vehicle being tested undergoes a strict driving timetable. One commonly used driving schedule is the Federal Test Procedure, which was established by the Environmental Protection Agency to simulate urban driving conditions. This schedule puts the vehicle being tested through a number of acceleration and deceleration periods. It consists of 3 phases: the cold start, stabilized, and hot start phase. The hot start and cold start phases are identical in terms of the driving pattern. The only difference between the two is that the cold start phase begins with a cold engine and the hot start phase begins with a hot engine. The test duration is set at 1,874 seconds. The test is performed a minimum of 3 times. The uncertainty incurred with such a small sample size is minimized by strict regulations required during the testing procedure. These regulations include quality checkpoints, frequent instrument calibration, and driving tolerances. However, some level of uncertainty is inherent in all scientific endeavors. After the completion of each testing cycle, the particulate filters are carefully removed from the filter holders to be weighed. The filters are transported to a stabilized environment where temperature, humidity, and cleanliness are closely monitored and controlled. Within this area, the sample filters are handled with care, using tweezers to place the filters on a very sensitive scale to record their weight. The scale is sensitive to such a degree that air movement can cause misreading and must be controlled. Finally, the weight of the sample filters are compared to the weight of reference filters that are made of the same material and were predetermined to have the same weight as the sample filters. By comparing the weights of the reference and sample filters, and by performing some additional mathematical calculations, the level of particulate emissions coming from the test vehicle can be determined. These tests are performed by various entities. They include the EPA, car manufacturers, and research scientists. The desire for car manufacturers to have their vehicles meet emission standards can lead to biased results. Therefore, the EPA tries to minimize the bias by conducting audits and performing their own in-house tests. Tests performed by the car manufacturers and the EPA use their own funds, whereas research scientists get grants and funds from private and governmental entities, organizations like the California Department of Transportation or the U.S. Department of Energy.
So, what can you do? Currently, the UWEC is in the process of implementing a facility on campus to make biodiesel from waste oil. The facility would require a biodiesel processor to convert the used oil to biodiesel fuel. One proposed processor is the BioPro 190, developed by Springboard Biodiesel. The biodiesel it produces could be used for the facilities and management vehicles, as well as shuttles that transport people to and from campus. However, the university is experiencing setbacks related to funding, legal matters, and locations for equipment. Biodiesel projects have been implemented in other universities, such as the University of Wisconsin, River Falls, Indiana's Ball State University, and Middlebury College in Vermont. Multiple preliminary studies on these participating campuses have shown decreases in particulate emissions, along with reductions in carbon dioxide, sulfur, and carbon monoxide. These successes are reducing America's dependence on dirty fuels, and adding Eau Claire to this growing list would be exciting and encourage other schools to follow our lead. Furthermore, this would help Eau Claire meet the goals of emissions reduction listed in the President's Climate Commitment that was signed in 2007. The increasing participation of universities in the United States can improve the global climate by reducing the harmful burning of diesel fuel. The collective action of Eau Claire students and faculty is key to the project's success and timely implementation. Therefore, we strongly encourage viewers and students of Eau Claire to get involved by taking action. This involves talking to the appointed students of the Student Office of Sustainability and attending the weekly meetings held at 5 p.m. on Tuesdays in Davies Council Oak Room. Viewers can also contact the Sustainability Fellow, Christina Hupy, to learn more. Due to the constraints of this video, we were not able to present many of the additional benefits and amazing opportunities biodiesel has to offer. Therefore, we strongly recommend the viewer to do some additional research in order to learn more about this exciting renewable resource. Thank you for watching.